this. Give me the 5-number summary for 2000. The minimum is about what? About 6. Q1 is right about 14. Just realized I forgot to do this. There we go. Median, right about 20. Q3, 22.5. That one, if you bring it down to the number line, it's falling in between 22 and 23. And our maximum, 27. Right about 27. If you have something a little bit smaller than 27, that would be fine. What about 2010? Minimum, 8. Q1, 11. Median, 17. Q3, 20, and maximum, 28. There we go. Should be able to just read them from left to right. Please pay attention, because if they're not, like, sometimes they do minimum and then maximum and whatever. Just pay attention to the labels if they're asking you for the 5-number summary. It's always going to be minimum, then Q1, then median, then Q3, then the maximum. Q1 is also called the lower quartile. Q3 is also called the upper quartile. All right. The rest of our class today is dedicated to questions that you guys may have about your review. Does anybody need an extra copy of the review? Does anybody not have a copy of the review? Oh, sorry. You need one? Okay. Does anybody else need another copy of the review?
No.
You got it, okay. What ones do you guys want to talk about? Number 3? All right. Number 3. We are going to leave all of our answers as unreduced fractions. So we're going to pull all the information straight off the table. First one, we want to know the probability that a student is in 8th grade. So I want all the 8th graders over the grand total. How many total 8th graders? 250. Here's all my 8th graders. And the grand total? 900. So 250 over 900. And that would be my final answer. They said unreduced fractions, so we're just leaving it just like that. What's the probability that a person selected at random's favorite ice cream is strawberry? Or what is the probability of strawberry? So just like the other one, I want all strawberry in my numerator. Over the grand total in the denominator. How many people total said they liked strawberry? How much? It's not 82. 367, because I'm looking at the one that says total over here. I think you just needed to go one column over. So right here, this is all strawberry. So 367 out of 900, and then leave it just like that. Right, now we start getting into some given that's. The probability that a person selected is a 6th grader, given that she prefers swirl ice cream, or the probability of 6th, given that swirl. Whenever we have a given that, whatever comes second, all of that goes on the bottom. So I want all swirl on the bottom. And on the top, I want the intersection between the first and the second event. So the 6th and swirl. What is the grand total for swirl? 533. Here's all swirl. And then I want the intersection between swirl and 6th grade. Where are those two intersecting at? 212. So there's my answer on part C. What's the probability that an 8th grader selected at random prefers strawberry ice cream? Or the probability of strawberry given that 8th? So again, whatever comes after the given that, all of that goes on the bottom. So I want all 8th graders on the bottom. And in the numerator, I want the intersection of the two events. How many 8th graders total do we have? 250. And then I need the intersection of all of the 8th graders with strawberry. Where is that intersection at? 82. Last one. Part E. What is the probability that a randomly selected student is a 7th grader that prefers swirl ice cream? Or the probability of 7th and swirl. Do we have a given that this time? No. So my denominator is going to be the grand total. And my numerator is this intersection, 7th and swirl. So what's my denominator? 900. My numerator, I need the intersection of 7th, which is right here, and swirl, which is going to be what? 153. Kind of hard to read those numbers up there. Hopefully you guys can see the numbers better on your page. What else do you guys want to see from the review? Number 1, absolutely. There are blank total students at Smallville High School. So for my total students, we need to add all the numbers. So I'm going to add 71, 93, 28, and this 202 that's down in the corner. What do you get when you add all of those together? $394. So there are 394 total students at the school. Blank students do not drive and do not have a job. Well, if they do not drive, then they would not be inside this circle. If they do not have a job, they would not be inside this circle. So I want all the people that are not in either of those circles. How many people are not in either one of those circles? 202. What does this symbol right here mean again? This one right here. That's a union. That's an or. What does it mean to unite things, to have a union? To put it together. So I'm going to take this circle and put it together with this circle. Well, here's students who drive. Put it together with this circle. So I need all of the students that are in those circles, which means I need to add up how many numbers? I need to add 3. I need every single number that's inside these two circles put together. So I have to add all 3 of those numbers. So I'm going to do 71 plus 93 plus 28. And we would get what? 192. Union or, we're going to add all the numbers in both circles. What is this 71 then? Students who drive, but they don't have a job. If they drove and had a job, they would be where? In the middle here. So what is this 28? Over here? Students that have a job, but don't drive, yes. So if I want all the students who drive together with all the students that have a job, I'm going to count all the students who drive but don't have a job, the students who drive and have a job, and the students who have a job but don't drive. I want all of them. That's why I'm adding all three of those numbers together. What is the symbol right below this one right here? That's an and. Just like we had two words for this symbol, that's a union, that's an or. I have two words here for this symbol. This is an and, or we could also call it what? Intersection. So I want the students who drive and have a job. I want where these two circles are intersecting each other, where they're overlapping. Where is that in the picture? 93, it's this spot right in the middle. They're in the students who drive circle, and they're also in the students who have a job circle. Total number of students who drive. Here's the students who drive circle. So I need everybody in that circle. These are all the students who drive. How am I going to find that total? Add it together. So I want 71 plus 93. And I get what? 164. Total number of students who have a job. Now I want everybody who is anywhere in the have a job circle, which does include that overlap again. How do I find that number? Add. What am I adding? 93 plus 28. And when I add 93 and 28 together, I get 121. Very last question has a symbol in it that we've not seen in any of the other parts up above. What's the P mean? Probability. If it says probability, I'm going to write a fraction, a decimal, or a percent. In this case, I'm going to write a fraction because I have all the numbers that would go in my numerator and in my denominator. What's going to go in the denominator for something like this? The total number. What's our total number? 394. That's the grand total of all the students at the school. In my numerator, I want all the students who drive. What was that one? All the students who drive? 164, because remember, all the students who drive, I have to include everything in that circle. So 164. Just because I know it sometimes shows up on multiple choice type things, and yesterday when we were playing the Kahoot, it showed up this way too, where they gave us a situation like this, but then all the answer choices were in decimal form. Can you guys pop that into your calculators and tell me what that would be in its decimal form? 0.416. So if you're a student at this school, there's a little bit more than a 41% chance that you drive, or 40% of the students at this school drive. What else would you guys like to see from the review? Yes, ma'am. Number 10, absolutely. We want to know if these events are independent. If they are independent, then the probability of event A multiplied by the probability of event B will be exactly the same as the probability of A and B. So I'm going to come over here and I'm going to ask myself, does the probability of A times the probability of B equal the probability of A and B? And then I'm going to substitute in what they gave me. What do we have for the probability of event A? 1/7. So I'm going to put that in the place of this right here, 1/7. What about the probability of event B? 3/5. So I'm going to put that in the place of this. And I'm going to multiply those two together. How do we multiply fractions together? Straight across. So what's this going to look like after I multiply them? 3/35. What did they tell me about the probability of A and B? 3/35. Are these two things equal?
Yeah.
So what does that mean? They are or are not independent? They are independent. When it says, show your thinking and explain your reasoning, if you show all of this work, that explains your reasoning. What you're telling me there in symbol form is I know that for two things to be independent, if I multiply the probabilities of the events together, and that's the same as the probability that they both happen, then they're independent events. So that would be sufficient for explaining your reasoning. What else would you guys like to talk about? Number 11, which one? Number 2. So I'll do number 11 because it's up on the screen here, and then we'll go back and look at number 2. Number 11. A, B, and C. Do not overthink these. They are just as easy as you can possibly imagine. What do they tell us about the choices that we have for the first number? 5, 6, or 7. So how many options do we have? 3. What do they tell us about the second number? It can't be 5, 6, or 7. So if I know how many total numbers there are, I can just minus those 3 from it. How many total numbers are on this thing? 50. From 0 to 49. That is 50 options. So if they say it is not a 5, 6, or 7, I take 50 options and I subtract those 3, which would give me what? 47. That's what I'm going to put here. There are 47 options there. Last one says the number is even. If I have 50 options total, how many of those will be even? 25. Half of them will be even, half of them will be odd. So of these 50 options, half are even, half are odd. So we have 25 options here. That's all I need on parts A, B, and C. Part A, B, and C is all a lead up to part D right here. If I know that there's 3 options for the first number, 47 options for the second number, 25 options for the third number, and I want to know how many are possible given this information, what am I going to do with the 3, the 47, and the 25? Multiply them. So I take 3 times 47 times 25. Tell me what you get. Yes, 3,525 total possible bike lock codes. Mm-hmm.
I have a question for E.
Mm-hmm.
Since there's only one combination left in the shrine, is it 1 over 3,525?
That's exactly right. This is one specific code. So it is 1 out of 3,525. Or another way you could think about it and get the exact same answer, you could look at it per number guessed. So 6 is 1 out of 3 options. 28 is 1 out of 47 options. 10 is 1 out of 25 options. And if you multiply those, you get the exact same thing. I'm fine if you just look at it and you say, that's one code out of all the possible codes, so it's 1 out of my total. That's fine. I don't need to see any work for it. But I do want to talk about other ways that you could think through it in case you forget. Yes, sir. How do we get 25? We have 50 options total from 0 to 49. Half of them are even, half of them are odd. So half of 50 is going to be 25. Does that make sense? All right, part F. My next guess is 5, 17, 9. What's the probability that that is the bike lock code? Good guess. Look very carefully at it and look at the requirements up here. Does this code meet all of those requirements the way this one did? What's wrong? Last number is not even. So if I know the bike lock code meets these criteria, what's the chance that that is the right code? 0. It didn't meet this criteria. There is no possible way this is the right code because the last number has to be an even number. So our probability here is 0 because of that. If they'd picked 8 instead of 9, then it would have been this same answer. 5 is one of those 3 numbers. 17, that's not 5, 6, or 7. That's one of the 47 options. We have 25 even numbers, and that is not an even number. We did not make any choices there that were correct. So I would end up with 0 over 35/25, which is the same thing as 0. Last one. If before my first guess, I remember that the first number is 6, if I remember that piece, do I have to guess for the first number anymore? No. Don't need to guess for the first number anymore. So now instead of my first number being 1 out of 3 options, it's 1 out of 1 option. I know it's a 6. What's the probability I'll guess the rest of the code correctly on the first try? I'm going to have to pick 1 out of these 47 numbers for the second one, right? And I'm going to have to pick 1 out of these 25 numbers. So it's going to be 1 out of what? In my denominator, I'm doing 1 times 47 times 25. 1,175. Here's another way to kind of think of that. Since I'm not having to guess for the first number, there's only one option here. Nothing changed about the other two. I still have 47 here and 25 here. And then it would be 1 over that, because we're saying what's the chance I guess it on the first try. So I get 1 chance to get it right. We're going to go back and look at number 2 after this. Number 2 is a related question to this. It's a little bit different, though. On number 2, it says to open a safe, 5 numbers must be entered on a keypad. What numbers do we have to choose from on this keypad? 0 to 9. How many numbers is that? There are 10 options. If you're going to try to open a safe, does it matter what order you put the numbers in? Yes. So even though we're just entering these numbers, I would consider these things being treated differently, because if you switch their places, it makes a difference. So would we consider this a permutation or a combination? Permutation. Why? Yes. Because the order of the numbers matter. How many possible ways can you enter 5 numbers to open the safe? So we're entering 5 numbers. I'm going to draw a little blank line here for all 5 of those numbers. So this is going to represent the choices for my first number, the choices for my second number, options for third number, for fourth number, and for the fifth number. If you go to the store and you buy a safe, if you wanted to, could you set the code to be 00000? If you wanted to. Yeah. What about if you wanted to make it 11223? Off your phone, sir. Off your phone. So is it okay if the numbers repeat? How many options do I have for this first number? I have 10 options. I can pick any one of these 10 numbers. If I wanted to pick the same number for the second that I did for the first, is that okay? If I wanted to? Yeah, I could do like 1, 1, 2, 2, 3. So how many choices do I have for the second number? I still have 10 choices here. How many choices do I have for the third number? 10. For the fourth number? 10. For the fifth number? 10. What do I do with all those? Multiply them. I'm multiplying 10 by itself 5 times. 1, 2, 3, 4, 5 zeros. So there are 100,000 different possible ways you could enter the 5 numbers to open the safe. But then in part C, they throw me a bit of a curveball. They say if no numbers are repeated, I still have to enter 5 numbers to open this safe. How many options do I have for the first number in this safe? I have 10 for the first number, but I'm not allowed to repeat it for the second number now. So how many options do I have now? 9. For the third number? 8. For the fourth number? 7. And for the fifth number? 6. And what do I do with all of those? Multiply them. 10 times 9 times 8 times 7 times 6. And what is that? 30,240. That really cuts down on your possible choices, your possible codes, if you're not allowed to repeat numbers. It's almost 100, or no, almost 70,000 left. All right, then in part D, they're asking me questions about this. I want to know all of the correct mathematical representations for this idea right here. What does the exclamation point mean? Yes, ma'am. Oh, yes, sorry, thank you. I switched my numbers. Thank you for catching that. What does this exclamation point mean? Does anybody remember? Starts with an F. This exclamation point, when we have a number with an exclamation point next to it, what do we call that? Factorial. This piece right here means factorial. And when you see that exclamation point after a number, what does it mean we're doing? I know I can type it into my calculator and get the exclamation point. You hit the PRB button there. But what is the calculator doing when we tell it to do that? When it has a factorial, when you see that exclamation point, we're going to start with the number that they give us here. And then you're going to multiply it by every single number less than it until you get down to 1. Is that the same thing as this? No. It's got part of the right stuff, but no. What about the next one? Why not? Yeah, this would be 5 times 4 times 3 times 2 times 1. That is not the same as this at all. What do we have going on here? We have a fraction. We have it written as a fraction. So we've got 10 factorial on top. And on the bottom, we have 5 factorial. Would any of those cancel? Which ones cancel? All of the numbers at the bottom cancel with everything 5 and smaller. Is what I have left over the same thing as this? Then that's a correct representation of what's going on. What about the one next to it? Yes. Bottom left? No. 10p5. What does the p mean again? Permutation. Go ahead and enter that one into your calculator. 10p5. What does it come out to be? 30,240. It came out to be exactly the same, so that means the same thing. What does the C mean here in this next one? Combination. Did we say this was a permutation or a combination? We said it was a permutation, so it can't be that one, because that's not a permutation. What about this last one? It's an error. This says I only have 5 things total, and I'm going to choose 10 of them. If I only have 5 kids in my class, can I pick 10 kids to take outside? No. So that doesn't work. All right. The entire review is posted in Canvas, all of my solutions. If you go all the way down to the bottom of the page for today, right here, Module 10 Review Solutions. Paper review, what you guys should have in front of you, that's due tomorrow when you come in. The review here that says 2023, that's the one that's available for extra credit. Every question that you get right, every point that you get on it will be a point of extra credit. Yes, ma'am. Yes, you can go ahead and turn the bell work in today. Tomorrow is the absolute last possible day that I will accept any and all late work. No late work will be accepted after tomorrow. The extra credit will close and lock tomorrow at 11:59 p.m. Yep. Because I have to have some time. I've already gotten flooded with late work coming into me, and I have to have time to get it graded and put in the grade book before we take our final exams. It's going to take me about the whole week next week.